Hello, good morning. Everyone is there? Yes. So have you started to working with the some basic structure of machine learning? What do you think, guys? Am I audible? No. Let me know in the chat if you guys are working or not. So today we are going to work on the classification work. Actually, the point related with the correlation coefficient that we are going to work on the next week, and some points related with that as well. And this week means today and tomorrow we are going to work on imbalancing problem with the execution of with means with logistic regression. Okay, so imbalancing is a major problem, no? So these are the factors are important. Yeah, logistic regression. Until what point data is imbalanced in the ratio? Yeah, I will tell you today. No, not an issue. I think I'm invisible, right? I think we should go for the work now, right? The major problem related with the imbalancing, as well as we are going to discuss about logistic regression. We are not going today about deeper into the logistic regression, but whenever we go for the any classification problem, there we have an imbalancing problem. See what I'm saying? Whenever you have any classification concept or classification problem statement, that time definitely you will get a problem of imbalancing, right? So what kind of imbalancing? Imbalancing concept that comes under the categorical data. If suppose your prediction column is in categorical, that time we can use, that time we can get the imbalancing problem. So where we get and what kind of concept there we have implement, as well as I'm going to discuss about classification problems as well. So different problem statement I will show you, and implementation as well. Okay. So hope so you guys are there. Please let me know if you guys are there. Just let me know into chat. Yes. Okay. So the main thing about it. Okay. So the first thing you know that our major part is that pandas as a field, import numpy as a np, right? So data set. So I'll take a 2 to 3 data set and different factors as well, so that we can discuss about it. Data set pd dot read csv. So I'll take yesterday's file as well. Yesterday, credit card data set, credit card data set, I think you have, right? Let me know if you have or not. Because this data set that we have used in previously as well, means in data analysis purpose, right? So let me know if you having any problem, then we can definitely share it. I will tell you. I will share it. Share it. Wait, I will take another one data set so that can do it. Hmm. These startups. Another data set I will take. Diabetes, or I think wine quality is there. No? Okay, 3 data sets are there. I'll execute these files first. Dataset dot, I'll side by side check the info as well as I will go for shape. The total size is in 2,84,000. That is an your, see, this is credit card data set, right? This is credit card. So near about how many count that we have? The near about 30 columns are there almost. How much? 30 columns. If I want to check the shape, head, data set, and dot head, sorry, info. So info is tells you near about 30 columns are there. So class column is an probability, means binary classification. This one. So now, first I will discuss about. Don't worry, when I go for the heart attack data set, no, that time I will definitely share with you, because I have to check that properly that data set is present or not. But definitely we'll go for that. Okay. So now, if classification problem statement, if I'm going to discuss the way we have discussed about regression is in continuous values, right? So if I'm going to predict a continuous value prediction, dependent variable is in your continuous, then definitely you can use which one? Regression, right? So when I go for the classification, your dependent variable means your prediction value tells you categorical concept, means your classified data. So what kind of classified data? How many types of classification there we have? There we have the two types of classification problem, that is in binary classification and multi-classification. Means binary categorical data and multi-categorical data. Is it correct? Yes or no? Binary and multi-classification. Logistic and KNN. No, there we have the so many libraries. Logistic, KNN, SVM, and decision tree, naive bias, random forest. You will get to know everything. But today we are not going with the deeper into the library. We are going to discuss about the problems that we get into when we going to implement the logistic regression or classification problem. Okay. So not only we are not discussing about only logistic regression or KNN, only we are discussing about the classification problems. So that when we enter into the classification problem, or when we are going to implement classification algorithms, then definitely we have to know the background actors, background problems. These are the things, right? Binary and multi-categorical data. Now, so binary is nothing but if suppose your dependent variable, if you are expecting a probabilistic answer like a 0, 1, like a true, false, like suppose weather forecasting, if I'm discussing tomorrow will be the rain or not, tomorrow who will win the match, It's kind of nothing but binary classification, binary dependent variable. Is it correct? Yes or no? You guys are there, right? So binary classification. So if I'm thinking about multi-classification, just think about, suppose you are going to detect the face detection is there. Example, face detection, you will get in multiple faces, or object detection, you will get in multiple objects. So you are having the multi-categorial data, no? So dependency means dedicatedly you are finding something like a what? You are finding your output. No, your output should be the, in the regression, the way you are finding the continuous values, the price and the house price, car price, and if suppose if you are going with the math score, that isn't continuous. But here you are finding the multi-categorial data. And the previously we have seen that binary classification is different, multi classification is different. But in the multi classification, but in the binary classification, we have to know about what is that your category, is that your binary data is balanced or not. If suppose your data is suppose your model is learning imbalanced data, then model goes towards the bias, biasing towards the majoritical category. So that is the problem. That thing is major here. So how can we solve? What kind of data we can get? So we can check out this once again. Okay, so I'll go for the first data set dot head. So this head part, that is nothing but your credit card fraud detection. Okay, so see, from the time to amount, this is your independent variable. From time column to amount column, this is your independent variable. So independent variable is nothing but x. So v1, v2, v3, v4 is kind of problems while doing the credit card transaction. So how much transaction means, if suppose if I'm doing the credit card transaction, what type of problems we can get? So v1 is a problem, v2 is a problem, v3 is a problem. So this, the amount of numerical values they are calculated with that while transaction is doing. So that is given by the some uh, unknown unknown bank, and that bank shares you this kind of data. Means this is a real time data, but no one can share the credit card fraud detection data or any genuine data set. So internet means, on the internet casual side, maximum time you will get this kind of means same data set, where there is, you can go, you will get this kind of data. But we are not going to deeper into the input variables and independent variables. We are going to discuss here, that is in class. The class is there, right? So this independent line is nothing but this, a single row is nothing but your one transaction. When I pass this one transaction into the model tells you that transaction is true or not. If suppose that transaction isn't true, that isn't zero. If suppose that transaction isn't false, that is become a one. So whatever the things that we are going to do, that is imbalancing. We are checking no imbalancing or not. So that purpose, what I'm going to do here, data set, and I'm passing here. I'm passing here the column name. So column name is in class, and class dot. You know that. How do I check? How do I check how many count that present there? How do I check? Unique tells you that unique values. Count values, not actually value counts. It is, this is value counts. Is it correct? Sorry. So that class, what is the total size of that data set? What is the total size? See here, 2,84,806. Almost observation values become means almost we can get that near about 3 lakh, right? 2,84,000 around 3 lakhs data set we have. So out of that 2,84,000, we are having zeros, means true transaction as 2,84,315 and ones count is in 492. So just imagine if I make, if I go for the training purpose, if I go for the training to the model, is it possible that model can learn in the balanced manner? Is it possible? What do you think, guys? Are you getting what I'm telling to you? The way you are the way we are saying this one means zeros counting and ones count. If I'm passing this data to the model, what do you think? It is working properly? This will be the imbalance, no? So you know the process, that implementation. So you know what I'm going to do here. Let's go and implement. Let us go and implement logistic regression. I will not tell you the logic behind that because I will take a different session for the logistic regression and other means side by side. I will take another means KNN and SVM as well, so that you can get a comparison purpose. But now we are going to implement about this logistic regression. We can get the output as well, accuracy score as well, and then what we are going to do, we are going to change the count of zeros and ones. Means we should go for the balancing of your class categories, and then we will see the actual output. Means without imbalancing problem, how can I get how much I'm getting the accuracy, and after the balancing, how much we are getting the accuracy. Yes, Rahul, we are going to do the oversampling and undersampling here, and definitely you guys are going to enjoy, right? Yes. Can you tell me, guys, what is the next stage? If suppose if I'm going to implement the x-axis, x independent variable and y independent dependent variable, so how can I pass this data set? Can you? ILOC, it's correct. So I'm passing x is equals to data set. Is it correct? Dot ILOC, and in that I'm passing colon comma colon -1. So maximum you guys are thinking about -1. It's the same process we are doing here. See guys, your class column is present in the last position of the table. If suppose that is the main factor, it doesn't matter your always dependent variable comes and into the last position. Sometimes your second position, third position, fifth position also become that. Means that is become a dependent variable. So do not think like that you are always getting that last position. So that data set ilog is an predefined -1. No, actually you can get yourself also. Means where there is a dependent variable, that position should be passing into the x and y as well. Means respectively you can pass independent variable and dependent variable. So y is equals to data set dot ilog, sorry, and colon comma -1. So you know that x is having an independent variables. These are the 29 columns are there. So total 30 columns. So this is nothing but your rows, and this is nothing but your columns, right? This is nothing but your rows, and this is nothing but your columns. This is rows, this is columns. So -1, I'm passing single column, you will get. The way you are passing -1, that is nothing but your, yes, sir, I'm taking whole data set because for the understanding purpose, still we are not going to do any kind of the 1 lakh or 2 lakh of data set, but we'll go for the whole data set. Yes. If I have a take a column of 5 as a dependent variable, See, column of 5 in a logistic regression or classification, you will not get it. Means it's kind of continuous variable, no? So how can you get that one? If suppose you are, if you think about you want to take on fifth column, then you can pass here fifth column, no? Rahul is correct, right? So x and x you have to pass x you have to pass into the single, means you have to choose a column differently. No need to pass like iloc, means the way you are taking column range. No, do not take like this one. You have to take a square brackets here like this one, and you have to pass here 2 comma 3 comma 5, fifth column, seventh column, eighth column, ninth column, 10th column. Is it correct? Okay, so let's just move for next process so that we can go for the properly here. So x is there and y is there, not an issue. We get it easily. -1. Have to practice a lot. Yeah, actually, when we move forward into the machine learning, so you will get a huge amount of concepts there. And yesterday, I think those people are yesterday joined. I think the way we got in questions, the way we think about out of the machine learning, because machine learning gives you the steps, algorithmic concept, but it's not meaning that only take a data and pass it into the machine learning algorithm. You have to work on the lot of things, no? So which means model tuning you have to do. The the amount of testing set you are taking, amount of training set you are taking, amount of random state you are taking, every factor is different. And in that between, you have to take a proper module and go for the prediction purpose. Even you can't believe that accuracy score as well. So let's move forward here. So x-axis and y-axis we have sliced down. That is an independent variable, dependent variable. And if suppose if I'm going to work on training and testing, so what I have to pass from sklearn, what I have to pass, guys? From sklearn dot model underscore selection, is this correct? Selection import what? Train underscore test underscore. No, sir. First, we got an. We will discuss. We will go for the implementation of this one. We will check the actual output problem while getting imbalancing problem. Once we get that, no, then we go for the comparison purpose into the imbalancing. Means when you go for the balance, what is the comparison? What will be the difference between the accuracy? What will be the difference between the what observational values of output, right? So let's go for this. Not an issue. I will discuss everything. Okay. Train test split, X test, sorry, train, comma, X test, comma, Y train, comma, Y test. Okay. So this is X, comma, Y, comma. You should have to go for the test size equals to, suppose I will take on 0.2. Okay. 0.3 I will take, not an issue. It depends upon us how much data we can take. Okay. And a random state underscore state is equals to, I'll take an 11. It doesn't matter. So how much data you are passing into the random state, how much value you are passing into the random state. So once I get this one, X train, X test, Y train, Y test. Not an issue. Now, so little bit we move towards one point here. That is in logistic regression. Logistic regression has the same concept. What I'm telling to you, logistic regression. So first let's go for the implementation, and then we are going to discuss about whole journey. Means, sir, X train, X test, Y train. X train is not different. Wait. Oh, sorry. Thanks for informing, sir. I think yesterday's problem that we solved, no same concept I'm getting here. Yes, ma'am. You told me, no, that's okay. No problem. First, I will implement this one. Okay. Means I'm not explaining you logistic regression, but I will tell you the execution, and then we go for the imbalancing, the difference about it. From sklearn dot linear. So logistic also having a linear model. Okay. What I'm saying, linear model, and import logistic regression. Logistic regression. So here also log. I'm just creating an object logs and logistic. Sorry. Random state is in 0 or 1. I'm taking 11. You can take any name, not an issue. Yes, sir. Logistic regression, not an issue. Okay. So what is the next step that we have to do? Logs. Do not worry about this one. What I'm doing means why I'm passing logistic regression without explaining. Do not go with this. No problem. Comma. Data is having so much. You can pass here as well. Random underscore state. This is a warning actually. Not an issue. Okay, let's check out the size of this one first. I'll pass on 9 and check out the answer. Yeah, because limit is exceeding because data we have passed huge, almost 2,84,000. So that's why he's taking. But not an issue. Not an issue. This is a warning actually. But I will go for one thing. Not an issue. Your model is trained, not a problem. Because the total number of iteration reached a limit. Means iteration means you have passed a huge amount of data. That's why. Okay. Let's go for one more thing. This is a prediction purpose. But I'll do one thing here. From sklearn matrix import accuracy score. Accuracy. I think my spell is mistake maybe. Accuracy score. Hmm. That's the only thing. Yeah, got it. Yeah. You can pass here values means y read and y test so that you can get it values. So see what I'm doing here. Y. So I will explain these things. In the performance matrix, I will explain the accuracy score and all. And logistic regression, I will explain you the whole background logic. Not an issue. Test, comma, y, read. Okay. See how much we are getting. 99.87% accuracy. Can you believe on this accuracy? How much accuracy we got? Almost 100% accuracy. Means if I put a round up on AC, 100% she will give you 100% accuracy. Is it correct? So if even I can't believe on the output as well. So how I'm not believing on the output? Why? See, If suppose, see now we are going to discuss on imbalancing, right? So now we are going to discuss about it. Why I have implemented these all structure? Because the transactions that we have, near about only 1% transactions are fraud, and almost how much transaction is in true, near about 99.9% accuracy, means 99.9% transaction are true. So what we are going to discuss here, if suppose the majority of categorical data that biasing your answer, what I'm saying, that biasing your answer. So how to avoid that? Because model need to learn about balanced data set, no? Instead of getting a problem, instead of learning a huge amount of data of one category. If suppose sometimes happens there is a huge amount of, means 70 to 80% fraud data and 25% of your true transactions are there. So at that time definitely you will get a problem. So avoid this kind of problem, avoid this kind of structure. What we have to do? In balancing. So in balancing purpose that I'm going to implement this one, and I will show you the differentiation as well. Okay. So let's implement these points as well, and we'll discuss about the difference as well, means difference between the accuracy score. That in that also I'm passing. See what I'm saying? In that also means I will go for the balancing of these values, balancing of these categories, and then I will pass into the algorithm. And then that time also we'll check our accuracy as well. Okay, let's go for this one. Even we are not checking about your observational values, means if I'm passing any true transaction, he is giving us a true or not. If I'm passing a wrong answer, wrong transaction, then he is giving a wrong or not. Okay, still we haven't checked about this, but we are going to discuss about the accuracy as well as some in balancing this points as well. Okay, so the first point that I'm taking here, random oversampling. Okay, so random oversampling is nothing but, suppose if you have a binary classification and one is in lower minoritical class and second one is in majoritical class there. So random oversampling gives it randomly increase the count of minority till majoritical class, minority to majority. So who is in minority here? 1. Who is in majority here? 0. Who will be increased here? Who is going to increase here? 1. Why? 1 is in lower count. So check out how to implementation. It is increasing. Yes, Rahul, increase. Okay. Now we can go for the implementation. The first thing what we have to do. Match up to majority. Yes, you have to match up the majority till majority. So let's go for this one. First, you have to pass a library. Which library? Undersampling and oversampling libraries are there. Okay. So let's first I will add here from sklearn dot random. What I'm passing here? Random. So instead of I'm passing here first over. Okay. Over underscore sampling. Okay. Over sampling. Import. Which part you have to pass? Random over sampling. You can pass sampler. Okay. What I'm passing? Sampler. So sklearn dot over underscore sampling import random over sampler. Okay, that's correct. So let's go for creating a object. So which object you have to create here? Which object you have to create here? That is an random R1. So I can create it in R1 only. R1 and that random sampler. Even you can pass here random state as well. Means random over sampler, you can increase the count, no? So you can pass it there, not an issue. But how can you pass the code here now? Right? So passing the code here, you have to do one thing. Yes, I'm passing, sir. I will tell you. I will tell you. No problem. He will increase the count randomly, not an issue. X1 data, comma, Y1 data. See, I'm creating a two variables. So can you tell me the way I'm creating a two variables, you have to pass here what? R1. See, R1 dot fit into the bracket. So I can pass here fit resample also. Sorry. We are solving the imbalancing, right? Yes, yes, we are solving the imbalancing. Don't worry, don't worry. Still I'm going with that. X comma Y. Can you tell me? Here I'm taking two variables, X1 and Y1. That is different, not an issue. X1 data is for the independent variable. Y1 data is for the dependent variable. Is equals to R1 is my random over sampler. Random over sampler. Then I'm passing my method fit underscore resample. Okay. Into the bracket, I'm passing X and Y. Who is an X? Who is an X? Independent variable. And Y is nothing but your dependent variable. So you are passing, see what I'm passing. You are passing independent variable and dependent variable into R1. Who is an R1? Your random oversampler. Random. What is the work of random oversampler? He is going to increase the count. Now you will get to know that why, what kind of work we are going to do now, right? I will check as well. Yes, Rahul, you can. Okay, pass it, no problem. I will tell you another one concept as well. But we first check out this one. Okay. So you guys are thinking about y is having two categories, that is in 0 and 1, and 1 is an into minority. One's count we are going to increase into the majority, not an issue. But why you are taking x there? Why are you are taking independent variable there? Is it correct? This is the question. If I'm going to increase the count of minority, why to take independent variable? See guys, if I'm increasing the count of minority to majority, means once count till the 2,84,000 who is having the majoritical count, that count is increased near about your total count of data set. How much? Wait. Your total count of zeros, how much? 2,84,315, right? 2,84,000. That is in zeros count. And when I'm going to increase the ones count, 492 to how much? 48315 till 28315. So what is the total count of data set? 5 lakh, almost 5 lakh, means almost 6 lakh something. Is it correct? No. Yes. Means 5 lakh something data you are having there. Okay. Your zeros count and ones count in front of you. Not an issue. If I execute this one, wait, what is happening here? Oh, sorry. Actually, this part not an so in scalar. You have to pass here IMBLEARN. IMB learn means imbalancing libraries that we have. Actually, by mistakenly, I have passed the scalar. You have to pass here IMB learn. Okay, imbalancing library. If I execute this one, check out. So executed. Check out what I'm going to do here. I think hope so. Everyone is there. I will tell you, Rahul, and explain you these things as well. Not an issue. So that purpose, we have to pass for the checking purpose. I have to pass here counter library. So for the counter library, I have to pass here one thing for the counter. I'll take counter library with, or directly I have to pass. I have to pass the counter library. Okay. So for the counter library, I'll pass one concept here because I want to check the count. No, directly you can pass through the unique as well as the value count, but that is become a yes outdated. I am module not found error. No module named IMB learn. No, you will get through the else check out the your anaconda is updated or not. Right, Rahul? Please check out that. Because if suppose your updated is not coming, no, that's why. So I'll use this one. See, this is an original. Okay, this is original. That is an counter. Okay, so I'm just taking the collection library that giving us any mathematical functional and collection problem solving libraries and classes. So that I'm taking the counter and counter y. So the how much categories are present, no, that he will give the count as well. So I'm passing here counter y. So y, your actual y data is here, original y data. So you can pass here actual as well. So actual y data cat, actual y data category. Okay. So that is in, and after balancing, after balancing, see, so what we have passed here after balancing y1 underscore data. So he, see here I'm passing x data and y data into the x1 underscore data, y1 underscore data, and that y1 underscore data. So guys, if I'm making this execution, sorry, check out 0, 2,84,315, 2,84,315. So what is the original size? Zeros count is 2,84,315. Ones count 490 in previously. And when I applied this random oversampler, that time I'm getting this, right? So now, guys, I'm thinking about the way I'm increasing the minority to majority. Here, not only increasing the count of dependent variable, means it's this random oversampler is not worked on the only dependent variable, he worked on the independent variable as well. Is it correct? So can we check for that count as well? Because side by side he's working same, no? Yes or no? Are you there, guys, everyone? See, x1 underscore data, and I'm thinking about y1 underscore data, that is the same. The independent variables as in 5,68,000 something, and dependent variable 5,68,000 something. So can you tell me what is the drawback of this random oversampler? Can you tell me the drawback of this? Yeah, he added the random data. See, dependent variable he increasing, not an issue, because he only increased the ones count, not an issue, not a big deal. But he is increasing the redundant data as well. So yeah, no realistic data. See, he increased the independent variables as well. So he's not creating himself a new data set. He's just making a copy paste, means he's creating a duplication of data. So whenever you have interviews, that time you have to tell them that a duplication of data is heavy, means increased, but you cannot tell them like increasing the count of, means increasing the duplication of data into dependent variable, because dependent variable has an only two counts. One's count is unstable, means zeros count is remains stable, that is in 2,84,000, but one's count is in how much? Increased. Only one thing is increased into dependent variable, that is in one's count. Duplicated from majority, right? See, duplicated from the majority. No, means if I'm discussing about x is an independent variable, so where he can take that data, means if suppose you are increasing the x, that y dependent variable, the way I'm just discussing about this one just before. So the way he's increasing the size of till 2,84,315, not an issue, till the 492 to 3 means still 3 lakh. But side by side independent variable also there. Only dependent variable you are increasing, that is a wrong thing, no? What do you think, guys? Is it correct what I'm discussing with you? So always think about it. If suppose if I'm increasing the dependent variable side by side, your independent variables also that should be increased. If suppose this is working on no, why not I pass this data into the logistic regression and then check the accuracy score as well? So how much difference, how much uh, the bifurcation between the actual data and when I use the random oversampler, how much difference we get it? That is the major point we have to discuss now. Is it correct, guys? Can we go for that checking? So what I'm going to do one thing here. So still accuracy will not be okay as of its drawback of copying data. Yes, yes, that good point actually. Rohan, you know what? Francis sir, actually you are correct because not in realistic data because duplication of data is there, not an issue. Uh, it's for if you are achieving a balancing, definitely you're not making you are not passing their actual or the realistic data into that for making accuracy, for making a balancing. You don't have an other option as well. So increasing the point of balancing. One thing you can go for the decreasing as well. Decreasing is also it depends upon you, right? Means decreasing in is nothing but your minority means undersampling. That is also we are going to discuss about it, not an issue. Another one thing from today's session, from today's session to till end of this course, you will get a huge amount of uh, types, huge amount of concepts. Why? Because the way you are working on the machine learning is gives you a predefined libraries as well as the steps. But it depends upon you how you are going to use the steps and concepts in problem solution technique. This is a general means general concept, and this means this part means presence of mind and these things that comes when only and only exercise. If you are not doing any exercise, definitely within a 1 week, within a 2 weeks, you will get confused a whole just thing, whole this journey. Are you getting, guys? Hope you understand my points. Yes, so, Rahul, definitely. So I'll create here last regression model again. Okay, so I'll copy this one and passing into the file here, and I'll create a logs I'll pass here over. Okay, log over, and here also log over because I'm using oversampling. That's why I'm creating a name object name as a log over. Okay, so when I execute this one, okay, log over is here. So I'm side by side. I'm just going to do here. Instead of doing Y-Prid, why not I go for accuracy score, right? So while doing this one, I'll take this part. Okay, my mistake is here. I have to pass their data is in different, right? So X train is in Y train is in. I'm not passing here. I'll pass. I have to do slicing here as well. Now got the point where we are passing that oversampling data, where x data and y data into splitting, and we are going to split down. So I'll pass here x1, x1, y1, y1. Why I'm passing y1, x1, y1? Because previously we have taken this variable. That's why I'm changing the names here. Okay, so do not get confused about it. So I'm not changing the test size equals to 0.3 and random state is equals to 9. Is it correct, guys? What I'm doing? Is it correct? Are you getting points, man? Okay. So executed. I'll pass here x1 train and y1 train because of training purpose. And finally, we have passed x1 train and y1 train to the model. And here, yeah, now he has done proper execution now, right? And without any warning, he has done. What? Good. Okay. So what I'm going to do here, wait. So you know that how much data we have into the x1 and y1. So total data set we got in how much? 5,68,000. So in that 30% is around 150, means 1.5 lakh, around 1.5 to 1.6 lakh, right? Out of 5,68,000 data set. So what I'm going to do here, I will change the object name of accuracy score y1, and okay, I have to do one thing here. Wait, y1 underscore pred, because prediction purpose I have to pass here data, sorry, equals to what is the log underscore over into the bracket. I'll pass here x1 underscore test. You know which part you have to pass? This one, for the testing purpose that we have taken. Okay. Sorry. Why random state two times? It doesn't matter, sir. The data you are splitting, no. The data you are splitting, that is into the trend test x, means training and testing set. While that data going to the model, that time also you can take, means that time also your data is running, means learning with the randomly. So you can pass the values is a 1, 2, and your data goes into the log over, means your logistic regression randomly as well. Means he learns randomly, not an issue. I will tell you Rahul step by step once I cover this point. Once I cover this point. What is the accuracy we got here? 93. Is it correct? And previously how much we got? 99. So just think about it. This is 99, right? This is 99. Right? After oversampling, we got a 93. Even we don't know that when we go for changing, see what I'm saying, the changes between the data test size, changes between the random state, means previously and now. So are you getting the difference between the data? Are you getting the difference between the accuracy? Means data also are giving a difference, because in previously when we have done plain data set, when we have passed imbalanced data set to the model gives you 99% of accuracy, means almost 100% of accuracy he has given. He already given. But when I made a balanced your categorical data, when I made a balancing of data, then he changed the accuracy with the 93%. So this is a big difference between the accuracies. So yes, sir. Undersampling would have a more accurate result. See, actually, point is that how much data we are passing to the model first, and how means the data is balanced or not. If suppose if I'm doing the undersampling, you are losing huge amount of data, because your undersampling count. What is the definition of undersampling? That is a majoritical count to the minority. So minoritical count, it is how much it is? Only 492. Yes or no? Your minority count is in only 492, and you are losing near about 2,84,000 data till how much you are degrading? 492. Yes, it is. See, the matter of discussion here. So every time the way we are getting into the credit card data set, the way we are getting categories into the credit card data set, it's not like that. Actually, a credit card data set, definitely he will give you a lower count of fraud. Why? Because if suppose you are getting thousands of credit card frauds into the banking sector, then why they are bringing this kind of structure into the public sector? If thousands of credit card frauds are, if credit card frauds they are getting, definitely you will get a lower count in the credit card. But not only credit card fraud detection, if you go for some other projects as well, there is an minoritical count is similar kind of, means suppose majoritical count is 100 and my minoritical count is some around 70, 80. So that time you can go for the undersampling. uh, will lose a lot of data. Yes, definitely. In the credit card, if I'm going to use undersampling, definitely you will lose a data. Yeah, but oversampling consists of garbage data. That's why you are getting 93. Yes, garbage means you are copying your data, own data to the till the getting a majoritical count. That's why. How can one depend on the garbage data? Yes, definitely. See, garbage is nothing but you are increasing your own data. So it depends upon us. We can means we can say that garbage, or you can say duplication of data, right? Because your own data is increasing there, not in creating any synthetically data there, means not in creating any kind of like means own data set, own data is not creating here. Okay, how do we know that we have to do over or under just and looking at the numbers? Actually, this is a good question. Means how can I decide this undersampling or oversampling? See, if I'm thinking about credit card fraud detection, I will not go with the undersampling. Why? Because if I'm going to teach a model, if I'm doing undersampling and your undersampling major minoritical count is in 492, is it correct? No. So how can I degrade your whole data set 2,84,000 till at the end? Is it correct? Am I correct? Whose question is that? Is I think Rahul. Yes. I think hope you got the point. Means why should I go for this one, right? That's why what I asked earlier. What's the ratio? Ratio. See, It depends. The ratio is depends on the it's hour base. Means not a standard ratio is there that you can use. See, if I'm thinking about testing size, there is a not a ratio kind of things. Means even I'm thinking about 50-50 you are teaching to the model and you are asking 50%, definitely your model not goes into the above 60% of accuracy. If I'm going to teach a 70-30 or 80-20, then definitely your model reaching towards that 70 to above. Is it correct? No, Rahul? I know some questions you are getting so many questions here, and that's good actually. Without any if suppose if you don't know, if you are not understanding, then definitely you will not get any questions. You are getting this point. That's why you are getting questions. You are having questions. Questions. So many questions actually I have here. The fraud actually less and prediction it should be also less. Yeah. Even I am not passing any observational data into the model. That's why. Yes, but you are telling to the model is that you have the same numbers of cases. That's fraud and not fraud. Okay. Mhm. What does that 99% defect means? Means you are saying that if your accuracy, if suppose you are getting an accuracy of 99%, what is the probability that we are getting accurate answer? Is it correct? What you are saying? Is it for accuracy is a 99 means what? What is accurate? Accuracy is 99% is nothing but your model is your accuracy score is checking your accuracy means uh, you are passing X data means check out here. Wait. What is 99% which data? True data or false data? That isn't combined means we are passing observational values and he whatever the output you are passing, no, whatever the y test and y field you are passing, he's checking his comparison. He's doing the comparison with the actual data and prediction values. Are you getting? And he's telling you a 93% of your data is matching to the actual data. Means that is 93% accuracy is there. Because you are passing y1 underscore test and you are comparing y1 underscore fraud. So no, not 7% is fraud. 7% is a wrong output. 7% is an not matching means y1 means your y pred is not matching to the y test. You cannot say that isn't fraud or that isn't true. Yes, sir. Yes. 99% of prediction values are same as the actual. That's correct, sir. That's correct. 1% are not matching. 1% is not matching to the actual prediction. That's the correct thing now. See, still I'm not discussing about actual means accuracy score means still we haven't gone through the performance matrix. But for the understanding purpose, I have to tell this whole journey. For understanding the random oversampling, that's why I'm just telling you this whole journey. Means the way we have discussed about the actual data is an imbalanced. Is it correct? No, actual data is an imbalanced. And if I'm passing to the model, if I'm passing to the model gives you the output of 99%. And even we haven't checked. See what I'm saying. It's not meaning, it's not meaning 99.87% is the way he has given. It's not meaning that model always gives you accuracy, means accurate answer. You have to, the yesterday, the way I have said that you have to slice down, you have to
make some 5 to 6 observational values from your own data set and checking the model as well. Even why not, means even he has given 100% of accuracy, right? Are you getting what I'm telling to you? After oversampling 50% of fraud and data and 50% of not fraud data, but actual data, the ratio was less. Uh, yes, means oversampling passing the 50 and 50% of 1 and 0 means true and false data as well. Even that also we are getting less, and definitely will get a less. No, it's your model. If suppose there is a small kid is there, and you are telling that child that this is an this is means you are teaching two different sectors, two different chapters, and it depends upon that child that how he is going to react on the test, right? Sometimes he not able to, it is kind of he never learn properly of some categories. It depends upon that child. But when we do the balancing, then the data increased 40%. Then how come the accuracy is a 93 of actual? Little bit confused. Actual, now I got the point. You actually, this is good question. See, actual, the way I'm applying the random oversampler, right? You are thinking about the way after increasing the 40% of data into the random oversampling, why not we create a custom, why not you create your custom x-test data from the what I'm saying, from the actual data set, without increasing, without applying the random oversampling, right? Now you are working with the, if suppose the way you are working with the before random sampling and after random sampling. Before random sampling, your data is imbalanced. After oversampling, your data is increased. Means you the way you said the 40% data is increased, and you are using comparison purpose same data set, not a previous data set. That's why you are getting question, and that's good actually, not an issue. That's a good question. Why? Because here also increased. No, is it correct what I'm saying? Here also increased your data, and I appreciate your questions actually. um, the way, if suppose the way if I'm passing a wipe read here for the testing purpose, for the checking the accuracy purpose, if you want to pass your previous data, you want to pass your previous actual data, then you have to create your whitest custom level. Means check, you have to take this previously here, this one, this data for the testing purpose. Is it correct, Francis sir? But this count and that wipe read count should be same. Are you getting? The way you said, no, the way you said that the 40% of data is increased. Is it correct? What I'm saying, the 40% of data is increased. So how can you believe that you are comparing your wipe read with the actual data? But wait, model one is your original data set, right? Model one is your original data, right? And this is imbalanced, means The imbalance is nothing but zeros count is an 2,84,000 and ones count is an almost 492. All right. So without any balancing, what I have done, I have made here x underscore test and your y pred is there, no? So with this accuracy, you are getting how much? 99% accuracy. This is correct. Now the second question, you got that model 2 has created, and this is balanced data. 0 is having 2,84,000 and 1 is having 2,84,000. But the point is that 2,84,000, 2,84,000. Better prepare some scenarios in models to explain the PPT with the comparison. No, this is different actually. Because if I'm going to compare with this point, no, because there is a test cases also changes, test size also changes. That's why I'm just coming with this one. Okay. So model 2 is unbalanced now. The way Francis sir said, see what I'm saying? The way Francis sir says, 2,84,000 is in your actual data, means before the balancing, and after that you are increasing almost 40% of data. That is the correct point. Yes, we have increased, and in that we have made x test again y pred, right? So here we got an almost 5,68,000 something, sorry, 5,68,000 something, and here we got how much? 2,84,000 something without balancing and with balancing. Now the question is that in this module you are getting 99%, but you can't believe on this model because your data is imbalanced, but you have an actual data. Is it correct? No, because here we don't have any kind of duplication of data. But then also we can't believe on this 99% accuracy. Why? Because you are having imbalanced, because model goes into the bias mode. But when I come to the point here, model 2 is giving us 93% of accuracy. Model 2 is giving a 93 accuracy. Then also we are getting some kind of problem, some kind of concept. Why? Because here we are having more than one duplicate data, but model is balanced. No. Everywhere is a problem. Actually, this kind of these are the assumptions, right? You are not making other data to pass into the, means you are not getting any kind of other data to passing into the model for the balancing purpose. You are increasing your own data set to the balancing. Is it correct? No. You are not passing other data, means you are not taking other data, HDFC Bank's data, or if suppose Axis Bank's data to passing to the making a balancing. You are increasing your own data set, no? So why to take attention? Okay. So the question that I got here, when you are balancing, why doesn't mean the balanced data? Why doesn't mean by balance? Yeah, actually, see, you are not passing here, you are increasing the data with a duplication, but you are having the observational values as well. You are not you are not making fraud data to true transaction. You are not doing true transaction to fraud data. You are increasing the count, no, true, true, true transaction, false, false, false transaction. Means what? You are not changing the behavior of your data. You are increasing the count only. So what's the problem? Oversampling. Are you getting? Balancing, always balancing is good. Now, I'm telling you, balancing is always good. But sometimes we can't believe on that. Why? If suppose sometimes your count is increased and duplication is increased, because you are increasing the count of your client's data, no? Client's data count you are increasing. See, true values and false values doesn't matter. You are passing your, if suppose if I'm telling 492 50 times increased to make a count of majoritical category. So why to take attention about increasing the count or duplication of data we are getting? You can take attention about when multi-categorical data will be there. Multi-categorical data. If suppose there is 7 to 8 counts are there, and what should I do? That time your customer is not buying that car, but making the balancing. You are saying that my customer is buy that car. When you say true, that means those many cases are frauds, which is balanced with the non-fraud data. Uh, the way I'm just trying to tell you that accuracy doesn't matter nowadays. The previously also I told you, accuracy isn't different, right? The first thing is that what type of data you are teaching to your model. If suppose you are teaching a duplication of data, duplicate data to the model, but you are training fraud to fraud data, no? Means you are not changing the behavioral part. If suppose your transaction having an 192 rupees of fraud transaction, and you are making a duplication of 192, 192, 192, but you are teaching fraud data, no? You are not teaching true transaction. Means you are not converting a true transactional data to the fraud. You are making just copying the fraud transactions continuously. Is it correct what I'm trying to tell you? Now the matter is that same count we are getting every data set? No, only credit card data set we are getting here, only 492. But when I go for some other data set, that time somehow 10 to 15% of data we are getting the imbalance. And yes, but lot of confusing now. Yeah, obviously confusing. Why? Because see, this is an first day of imbalancing. People spend near about 3 to 4 days to understand the problem statement. Are you getting what I'm telling to you? 3 to 4 days they are spending to understand the whole journey of this imbalancing, how much data is imbalanced, how much data is not imbalanced. But definitely I will tell you, I'm trying to give you more examples to understand for this one. And I know you will get in questions. Questions are important. Confusion, when confusion comes, when you are trying to understand these problems, all data values and similar means balanced. Count is balanced, sir. All data values similar means balanced. Means similar is and different. Similar is and duplication. And balanced is nothing but you're increasing the count. Yes, sir. Sampling means sampling is nothing but if suppose you are having a huge amount of data, means 1 lakh of data, and you are fetching thousands of data from the huge amount of data. That is nothing but you are taking the thousands of samples, and that huge amount of data in the stats they tells you population is there, is that is nothing but 1 lakh of data, and fetching 1000 samples, that is in samples and thousands of data, increasing the samples, decreasing the samples. what it what is a sampling frequency? Frequency is nothing but the same number, how many times that coming. Means suppose samples are, suppose you are taking 1000, and that same samples, same count, same observations, how many times that increasing into the whole data set. That is in sampling frequency. Is that correct, sir? Yes, obviously. That if suppose changes, even you saw that there is a random state is there. Random state is there. You are teaching to the model, they are randomly pick up in the data, right? Definitely it changes, sir. Rahul, same count may have came in here above while oversampling. Yes, same count means same observations also coming there, not an issue. Where do we define the sampling rate? Sampling rate means you are passing. Please upload the PPT and theory as well. I will pass the theory part is there, uh, samplings and all, no problem. Sampling rate you can pass, but you know, sir, sampling rate if I'm going to pass into the here means random oversampler. This part is not sampling rate passing here will not come into that because if I pass the sampling rate, no, that comes into the uh, model, because how many samples means how many thousands or 5,000 samples you want. That is, I think that point that we will get into the random forest means sampling how much samples you want to create, that much. Francis sir, I think sampling rate is nothing but count 5,000 samples, 8,000 samples you want to take. That is how to predict oversampling or undersampling, which one we use. Still confusing. Don't worry, Rahul. Cool down. This is the first day on this classification and imbalancing, but definitely will learn. No problem. Yeah, anyone, guys, you know the some points. No, definitely go for that. See, even I'm eager to learn from your side as well. If you know something, then share it with the. Yes, Francis. Assuming the say that you have 1,000 records, so we can say the 5% samples and records and falling all false, then the accuracy will affect. Yes, definitely affects. How do we know that if same samples has taken true or false data? Uh, Whatever the samples you are passing into the prediction purpose, no, you have to check out the previous day as well. Means the way you're asking to the model, no, that is unbalanced or not. So that purpose you have to pass their counterers, means value counts as well. There we have. There should be a difference best practice on the sampling rate, difference domain of data. Yeah. So finally, what should we do the regarding this one? See now, first thing, you just implement first random sampling. Implement. Do not change the test size. Do not change the random state as well. Change only random. Implement only random state. Previous one is original implementation as well as this implementation. Okay. Check out the difference. Check out the pass the test cases as well. Means test cases is nothing but pass the observational values as well. First, pass the extract data as well. Yes, definitely. Okay, Arun Sade. Yes, you will. First day ahe, so take a chill, no problem. Okay, sampling graph and its type also comes into the matplotlib. A sampling graph and its type also comes into matplotlib. No, actually, sampling graph you can take, not an issue. But why to go for that heaviest thing? What I means making a graphical representation all. Only at the end we want that samples are balanced or not, right? So how many means depends upon the depends upon the categorical concept. So do not worry about it. But the first thing, you just go for the implementation of this random oversampling. What is the consideration acceptable in terms of accuracy? Accuracy always comes under the dependent on the data, means observational values. And when if I pass that, if suppose you trust on the observational values, then definitely you can believe on the accuracy as well. The terms that I said above, always 75% above. If you go for the accuracy, always I believe on that. But when I believe, when your observational data is true and strong, that time only. I think that will be the picked according to the random state, and the random state isn't passed into the picked on, but if between the difference result. Oh, still we are discussing on the balancing and imbalancing. But don't worry, you the way you guys discuss, no, that isn't huge, huge. I appreciate your opinions and discussion as well, because of your understanding. That's why you are discussing. No, yeah. But don't worry, guys. And tomorrow's session also, we are going to work on the different cases, different scenarios, undersampling as well as other things as well. But we'll go for that, and we'll come tomorrow's session as well. Hope you enjoyed today's session, right? And thank you so much for this joining this session. See you on tomorrow. Thank you so much. Yeah, thank you so much. Yeah, thank you. Yes, I will upload. Yeah, sure.